contactor for an HVAC or heating and air conditioning unit, namely to convey high voltage from one side to the other side, meaning that 120 here would jump 120 here when the contactor is pulled in. This little gizmo here, kind of as one can see, once this is pulled in. Now this can be done manually, but there would be 120 on this leg, 120 on this leg. So once the contactor's pulled in, this 120 jumps from here. So now you have 120 here, 120 here. 120 plus 120 is 240. 120 plus 120 is 240 here. So the question being, number one, what is the contactor for? Think of it like a off and on switch. It powers up in the condenser outside. It powers the compressor and it powers the condenser fan motor. So if it's energized here, if this is pulled in by the low voltage and the high voltage goes here, high voltage goes here, now we have high voltage. But once a certain criteria is met, or criterion is met, then the system would cut it off. And when one would say the criteria being met, what does this actually mean? This actually could mean your thermostat, say, if you're on the air conditioning mode and it satisfies the particular temperature that you're wanting to achieve on your thermostat, once that's satisfied, it breaks contact and this cuts off. So if it does not cut off, what happens then is the system just continuously runs, and as one can infer, the continuous charge of electricity without rest will eventually either burn the motor up, whether that be a compressor or whether that be the condenser fan motor, notwithstanding. So now the question here, as one can see on this contactor, it has the little pull thing. So the question, well, what energizes this to make this voltage jump here? It's actually low voltage. So how could we get low voltage over here? Well, low voltage is 24 volts, say the thermostat wire. If we did it this way, now there may be another way to put a cap on here. And by the way, if the HVAC guys could put in the comments what's the best color to use for 24 volts, or one could use the stranded wire and put two of these onto the stranded wire and then tie the stranded wire to the solid wire. But if we went straight to it, we would have a hot and for the condenser and a common. So what we would do, we've actually put one of the spade connectors on here now, as one can see a spade connector. So we go over here to the low voltage side and we simply do this number here. And it's tough to see, but we go here and see, the stranded wire gives you a little bit more flexibility than the solid wire. But notwithstanding, the example may not hurt. So if we go here, and then if we go here on the other side, and then if we go here, now we made a contact. We made the low voltage on one side and the low voltage on the other side. We may be better to use a yellow spade connector. I'm not sure, but I'm not sure which spade connector would be better. Now this would be here. We could remove this and go to this particular terminal here. So now, what we have now is we have a lot of gibberish here, and I do apologize, but we have a hot and a common. So now the hot and the common, if the thermostat energizes 24 volts, it should pull this in, and once it pulls this in, it creates a magnetic field, and this is this magnetic field will convey the electricity from this side to this side. So again, this is the low voltage side, as one can see. And again, if the HVAC gurus can put what would be the best spade connector. Now, there is another way to do this. One could put the spade connector onto a wire, and some of them may have it like a stranded wire, so it's more bendable than the solid wire, and do it this way. I'm not sure that it makes that much difference. If the HVAC guys can add this, that would be good. But basically, we're putting 24 volts here. We've got a hot and a common. Do keep in mind now, some people will wire from the terminal track, from the terminal strip in the air handler, a red wire in this. So if you see a red wire on here, don't be alarmed. Basically, they may tie this in on the terminal strip at the heating and air. So basically, this would go this would be your hot wire, this would be your common, this would be your incoming voltage, this would be your return voltage. And what this would do when the thermostat calls for cooling, it would simply energize this. When it energizes this, the coil on the bottom, as one can see here, that coil there will be energized, and the voltage will jump over there. So this is how you could, one way you could wire the low voltage up to a contactor to engage low voltage to high voltage. Thank you for watching.